So in 10-6 problems, you'll be having to use both those concepts of setting up the ratio and using your calculator to find the tangent of the angle or sine of the angle or cosine of the angle. So you'll be given a problem, find the value of x to the nearest tenth, and we will be given the drawing, and you have to figure out if you're going to be using sine, cosine, or tangent. So if I look at my drawing and I have the hypotenuse, that automatically means that tangent is not going to be involved because it doesn't use the hypotenuse. So now I have to narrow it down. Do I have the opposite or the adjacent side? So if I look at my angle, I'm going across the triangle, so I have the opposite and the hypotenuse, which is sine. So I go sine of my angle, 48 degrees, is equal to my opposite side, x, over my hypotenuse, which is 14. So you always set up the equation, and then you go about solving it. So when I go to solve, I want x by itself. So what I have to do is multiply by 14, just like we solve any other math problem. That will cancel this out and leave x by itself. The left side, I'm going to put in the calculator. So I get my scientific calculator, go 14 sine 48. Again, I don't need the parenthesis, but I can put it in there if I want. And that will multiply 14 times the sine of 48, which is 10.4 when rounded to the nearest tenth. And we have solved this problem. Now when you go and look at another problem, so we have problem 2 here. We have 41 degrees and we have two sides, 25 and x. If we look at the two, we have, again, the opposite and the hypotenuse. It's not going to be solved exactly like this previous problem, because when we set it up, my sine of 41 degrees is equal to my opposite of 25 divided by my hypotenuse, which is x. On the previous problem, x was in the numerator. In this one, x is in the denominator. So I need to multiply both sides by x. So it cancels out here. So I have x sine of 41 is equal to 25. And now I want to divide by sine of 41. So that I get x by itself. Properties of proportions that you've worked with before. Whenever you have proportions, you can always switch what's on the diagonal. I just went through and did the actual proof of it. If I have my sine of 41 equals 25 over x, I can switch those two, move x to the top, and my sine of 41 goes down to the bottom. My 25 stays put. You need to see that one underneath this, the x, you can do that too. So now when you put this one in your calculator, I have 25 divided by sine of 41. And when I do that, I get 38.1. And now that problem is solved. So always set up your problem first. And that original problem was sine of 41 was equal to 25 divided by the x. And then go about solving it. So in problem 3 that I'm giving you an example of, I have my angle. I don't have my hypotenuse at all. So with SOHCAHTOA, the only one that does not use my hypotenuse is tangent. You can narrow it down rather quickly. So tangent of my angle, which was 36 degrees, is equal to the opposite, x, the adjacent 29. So since my x is in the numerator, I just have to multiply by 29. And my x now is equal to 29 times tan of 36. 29, tan, 36. And I get 21.06, so that would round to 21.1. If you were having to use the table, just to show you that example, in case you didn't have a scientific calculator at home. So tan of 36, I look and I go across at 36 is my angle, go across to tangent, I would have 29 times 0.7265, 29 times 7265, and I get the same exact answer. So either way, if you don't have the scientific or graphing calculator, you can use the table and still solve the problem. Just the last example is to find the value of x to the nearest degree. On these type of problems, you are not given your angle measure at all, but you still set it up the same way as if you were going to solve for your angle. So if I look at my sides, I have the opposite and hypotenuse. So I'd go sine of x equals, opposite side is 3, 4.24 is my hypotenuse. So 3 divided by 4.24 gives me the number of 0.7075. So with the graphing calculator, I now have to find my angle measure. So I use sine to the negative 1 of this 0.7075. And that will give me my angle measure. So with the graphing calculator, if you've already figured out your ratio and have its number, I can go second sine, second answer, and I'll put that 0.707 in there, and I get 45 degrees because I'm rounding to the nearest whole degree. If you didn't have this inverse sine function, you would have to take your chart, search it until you find 0.707 for your sine, and it is right there at 45 degrees. So either way, you can still find it. It works so much easier and faster if you use the scientific calculator to solve it.